Okay, so thanks for coming, guys. So today I'm going to be talking about Metaboard. It's something I've been working on kind of solo, and I'm wanting to sort of give it back to the community a bit more so other people can contribute to it. And so this is my way of explaining some of the details that might be a bit obscure at the moment. First of all, I'm Billy. Probably know me as Billy Price. I'm in the process of changing my name. My last name is now Snickers, not legally, but it'll eventually be that. So, but now is a good a time as any to debut that change. Um, and so yeah, the title is Metaboard, server-authoritative multi-user editing with undo, redo, and erasing. So I was a little inspired by last week's talk by Mr. Chicken Rocket, who went through. He also used the word server authoritative, and which is essentially a method of uh, making state more consistent between clients by giving the authority over the state of the world to the server. Um, and so the problems I encounter here are sort of similar to that, but because I have a lot more data I'm throwing around with Metaboard, the solution I think has to be a little bit different, and so I'm going to go through the solution I came up with today and talk about some of the advantages and some of the trade-offs I guess it has. Um, But just as an intro to what Metaboard is, I know probably everyone here right now has some understanding of what it's like, but maybe just so this seminar can serve as a sort of general introduction to what it is. I just want to talk about well, I guess here's the outline, and the first thing I want to talk about is what the ideal user experience is for using Metaboard uh, inside MetaUni. And I'll go through some of these other things throughout the talk. So I've got some pretty pictures here and something I want to say about these as I go through. So I think walking around MetaUni should feel like stumbling across a garden of ideas. And for some reason, these ideas felt important enough to write down. And yeah, so it's not just like your shared whiteboard in a Zoom meeting. And a critical part of that is its persistence in this space, which we call MetaUni. And like, I sort of struggle to like pinpoint the exact reasons why that's so important or critical, or like I think it's just one of the main reasons why we keep coming back to MetaUni and like contributing to it and organizing our like these seminars and communicating ideas through the medium of MetaUni. Um, and so yeah, they are the channel of communication for the complex ideas we're trying to get across to each other. But they also serve as a kind of byproduct of a hard day's work. Um, so yeah, so why is it so hard to pretend? Yeah, sorry. What something I wrote down was why try so hard to pretend that it's the real world? It's like it's the same question like what's wrong with just having this sort of shared whiteboard like in your regular Zoom app. Um, and Dan has mentioned a few times the idea of like a mind palace and just this idea that as humans we reason spatially, where like as we're communicating a lecture, it's not enough to just like say all the words and then like rely on the audience to sort of understand it and sort of keep it in their head. We don't just sort of think in a linear stream of thoughts. The way we communicate most effectively is by externalizing our ideas into this shared space that we're occupying. And as those ideas grow and have to sort of interact with each other, we like to see them placed in like concrete places around our shared space. And so that happens sort of within one board, but it also happens like across multiple boards. So that's why we have this we dedicate like real estate in our 3D space to like this is the place where this idea is going to sit there and live, and it's going to take up space, and someone can like as you move around, like you remember you saw this idea, the lecturer said something about this concept, and they wrote down some symbols or some pictures or something to sort of make that idea concrete, and it sits there, and you don't have to keep it like fully in your head. You sort of just keep a reference, and when some line of reasoning takes you back to that same concept, you go, "Oh, I remember where that was," because we have this human advantage of about spatial reasoning. And then I'm going to go back to that place and or look over there, and I can sort of I can reboot the state of my mind into like the thoughts I was having when I saw those symbols at that particular place in space. So, why am I saying all this? I guess I want to motivate that a super important part of Metaboard uh, that makes it all crumble if it doesn't work is that it needs to like it needs to be correct so that it preserves this illusion that that concept that was written down really is there and it lives there in the world, and it's not gonna like just disappear for no reason, or like there's certain cases in which that does happen, but there needs to be some kind of illusion that that you can sort of trust in, that it's going to that it's a real part of the space that you're in. So I've got some more pictures. Maybe I could have been scrolling through. I took some of these pictures yesterday, and uh, some of them are from the channels that Dan has posted some pictures in. Here's some old ones. Um, this is sort of uh, sequence of history boards which shows like what the board looked like over time in a previous seminar. And we've drawn some art from time to time when we're waiting for a seminar. Um, okay, so what I just described, I'm trying to motivate the sort of core requirements of Metaboard um, that that only come up, like most of these only come up when you're designing a drawing app that multiple people have to uh, interact with at the same time. And so let me go through these. So firstly, users must agree on what the board looks like. So here's an example where for some reason the first client is seeing the black line over the blue line, and the other client is seeing the blue line over the black line. So this alone might seem like a very subtle and important problem, but it's like when this happens, like here or there, it sort of this is one of those breaking the illusion moments where like you no longer trust that like that you're actually there seeing this thing that everyone else is seeing, and there's like commonality there. So all of a sudden it's just sort of this sort of broken uh like mirroring between what you're seeing and what other people are seeing. Um the next thing is users must be able to interact with the board simultaneously, because of course in real life we can do that, so why not in Metaboard? Um, and then these two requirements kind of sort of make it difficult to do these things at the same time. So all of these, like if you take one or just a couple of these at a time, it's kind of easy to like make sure it happens, but doing it all at once is the tricky bit. So the writing experience must be smooth and uncompromised, and um, yeah, Dan has really been writing me the past few weeks, making sure that it's as like smooth as possible. Because I guess my main goal uh, with this new version of Metaboard is I've been working on has been uh, working on the correctness side of things, and that like can, as a consequence, it can sacrifice some of this stuff. And so, yeah, it's kind of it's tricky but possible to strike a balance between these. Um, and the last thing, which is probably the biggest spanner in the works, is that existing content must be modifiable. So you need to be able to erase things that are already there, and you should, because mistakes happen, you need to be able to undo and redo. I guess the undo redo is like probably the maybe that counts as like an illusion breaking thing, but it's a like it's more towards the goal of making Metaboard a serious tool that is sort of up to scratch with like any other drawing tool. You kind of expect to be able to undo and redo. Um, so yeah, so those are the core requirements. And yeah, my thesis is that it's really difficult to do this in general when your model of how things work is that there is some state of what the board looks like that each client has and the server has their own copy of, and every action that you do to the board mutates or just destructively changes what that state is. Like the very directly, this makes it difficult to do undo redo, but it also interferes with some other stuff. And so I'm going to go through a couple examples to put you in my shoes about the kind of problems I need to solve all of these problems at once. And so here are a few dot points, and I'm going to try and illustrate some of the problems. I guess feel free to stop me and ask any questions if you have any. If I've said anything too fast, feel free to pull me up. Okay, so the first thing is Zed Index Conflicts. So I guess the bread and butter of like the content that we draw on these boards is a thing called a curve. And in this drawing app, it looks completely smooth. And I guess we're at a little bit of a disadvantage in the way that we render things in Metaboard, where what you actually see is a curve is made up of straight line segments. So at times it can look a bit jagged, and each of these points is a kind of moment in time where your cursor was, and we render that as one big curve by rendering a bunch of straight line segments that connect those points where your mouse or your pen was at. And okay, so these get rendered at some position on your board, but because like new lines need to be on top of old lines, there's the concept of a Z index, which tells you like in what order the line should go, like what line has precedent over another one. So here in this example, the black line has a higher Z index than the blue one, and here the blue one has a higher Z index than the black one. So let me explain how a problem like this can arise. So this is roughly how it would work if you're doing it in the sort of state mutating way. So what happens is client A, they take their pen and they draw a line, and a bunch of events get fired as the line is being drawn. But we can sort of for now pretend it sort of happens all at once. So let's say that's their like that's line A that they've drawn. I guess. Oh, they're also called client A. I'll just it'll be line A anyway. They draw their line. It appears on their screen immediately because we're just going to directly mutate what it looks like instantaneously. They send it to the server to say, hey, you need to change what your board looks like because I drew something. But you also need to tell all the other clients to change what their board looks like. But let's pretend that at the same time, client B is also drawing a line. So they're drawing line B, and they sort of notify the server about that. And it depends what order this happens. And actually, let's pretend that first client A, they like notified the server first, or that they have a lower ping, so their remote event reached the server first. The server says, okay, I'm going to sort of in this setting, the server has control over the like 3D board in the workspace, and the clients are sort of taking care of the GUI that they see in front of themselves. Okay, so the client A has drawn the line. It got to the server first, so the server draws it, and it has to notify all the other clients that it's drawn that line. So let's say now it sends the event of drawing that line to client B, and oh yeah, so I talked about there's a concept of a Z index, and at a particular point in time, the board stores what Z index it's up to. So that the next line drawn has to appear above all the other lines drawn. So it grabs the next Z index. So all of these clients sort of, let's say they all start knowing that the Z index is currently 0 because there was nothing written on the board at all. So the first line can appear at layer 0. And so this client draws this line at layer 0, and it tells this client to draw it at layer 0. But if this client here had already drawn this line and sent their remote event to the server to say, hey, I drew this line, and they're saying that their line is at layer 0, now everyone will be told that both the blue and the black line are at the same layer. And what happens is that in the 3D workspace, this ends up like the lines sort of clip into each other, and you see I think it's called Z fighting, where it just looks all like you see weird triangles and stuff because they're sort of cutting through each other at the exact same spot. And yeah, it also in the GUI, which is just it's not in the 3D space, it's just sort of rendering via GUI elements on your screen. If you have multiple frames at the same GUI Z index, it's not really deterministic, or you don't really know which line is going to be on top of each other. And so depending on how I choose to render this or that, you can't sort of trust that one is always going to, you can't know which one is going to be on top of the other one. So there's a sort of conflict on which line will be on top of each other. So yeah, so this is a sort of client to server problem. This one isn't such a huge problem on its own because you can sort of say this client can say, all right, draw this line at Z index 0. But then the server sort of knows that that this line came first before this line, so it can sort of revise the sort of properties of this line and say, actually, it should appear above on layer 1, and that can be sort of that client can be notified, and you can draw, you can redraw that black line on the correct layer, depending on what the Zed index should be according to the server. So that's a sort of it's one that's one simple problem, but that can be sort of revised. But let's go through some other ones. So if we're going to support erasing, there can be disagreement about what has been erased by a client. So let me erase this. I guess meta erase it. Okay, so let's suppose that like there's some stuff on the board, and you have client B like is deciding to erase. They decide to start erasing some of those lines. And this is their sort of first spot they're erasing. But at the same time, you've got client A wants to draw a line through there. And now what the order in which these events reach the server, this client A is drawing a line, client B is erasing roughly in the same spot. So you can see it's going to be erasing around there. The order that reaches the server changes the outcome of what the board should look like. So if client A reaches the server first, then you draw the line there, and then you erase, I guess, that much of it, because the erasing happens afterwards. But if client B gets there first, then what happens is that this gets erased, and then this line is drawn. And so who gets there first sort of determines how it's going to look. And whoever gets there first, if they just do the same things as the server, they will see the same result. So let's say that client A got there first, so the line was drawn, and then they got the event from client B, so this part got erased. Client B, well, they've already erased this part, and so when they because they did it immediately, when they get
Sorry,
the
Billy.
information.
This picture you're drawing in server, do you mean to be drawing it in client A to indicate the dependence on the order in which events are received, or?
Yeah, well, so it'll happen on both. So yeah, I guess it would make more sense to draw it on client A first. So okay, so client A draws that line, it gets to the server. Oops. No, it does happen on the server first. So this has happened. Client B hasn't received the event back that client A has drawn the line. They haven't got this yet. It's almost there. But before it got there, client B said, I'm going to erase right here. And so this gets erased here. And then the server is going to notify everyone that this part here gets erased. So it'll tell client A, so sort of the erase event will go to client A, and they'll do the same thing. They'll erase in that spot. And they'll also, maybe we don't send like the erase event back to client B because they already know they've done it. But eventually, I said that this event that client A drew the line is going to get to client B, and at that point, because they've already erased that spot, they'll just draw the line, and now they're seeing something different because they didn't know that that the line appeared there before they did that erasing, according to the server and client A. Does that make sense?
Yeah, I think you're implicitly assuming people understand that we're not just rendering. I mean, you could ask every frame for the server to tell you what's on the board, in which case this issue goes away, but you're kind of implicitly
exactly.
discussing a mix between client side taking charge of rendering and server side taking charge of rendering, right?
Yeah. So there's kind of a large space of like attempted solutions that have flaws. I'm going to show a version that sort of solves some of these problems, or solves these problems by doing it one particular way. And in getting there, I sort of went through a bunch of other like configurations of ways to solve the problem, and like went down a couple paths of what if we did this and this and this. But yeah, it's hard to address everything you could possibly do to solve these problems at once. But yeah, I hope it's clear enough. Yeah, so you suggested we could just wait for the server to like decide what happens, and then we only change what we see when it gets back to us. But that violates this principle here of making the writing experience smooth and uncompromised. So
that's the comment I wanted to elicit. Yeah. Mm-hmm.
Yeah. Okay. So here's one attempted solution. When this event gets back to client B, where they're told that actually this line is going to be drawn here, we could sort of involve some information about the client B can sort of infer the order that things happened, because maybe the server also sends back that erase event, and because they see that client A drew something before they get back their own erase event, they know that this needs to be drawn first, and then this needs to be erased. And that's exactly how you do that. Is a tough challenge, because there can be a lot of differences between the point in time that since you sent this event, a lot of things could have happened that you don't know about, and one method would be something like attempting to perform a maybe if we did it in the style that that Mr. Chicken Rocket was doing it yesterday last week. The concept was the server sort of sends back the sort of whole state of the board to client B, and they re-simulate what they've done since that point in time. And I won't go into details, but that's not really feasible because of the amount of you can have hundreds of thousands of, well, maybe not hundreds of thousands, but at least tens of thousands of lines on the board. And so,
to be fair, he sent back a compressed diff, right? If I remember correctly.
Yeah, so it's compressed, but the sort of the state being communicated there is just the position of a character, and you maybe have like 100 characters, and that's not a whole lot of data in comparison to the amount of data we have here. And I'm not just concerned about the sort of network usage there. It's also the question of, all right, how are you what does client B have to do? They have to rewind to this point before they did their erasing. And then they have to draw this, and then they have to recalculate that erasing stuff. There's sort of several ways you can do that, but if you're doing a lot of destroying instances and recreating instances every frame, that's completely intractable. You can't do it that way. So you need some kind of efficient reconciliation method for that. But this sort of jump to a previous state and resimulate, thinking about it that way, I do something like that. But you'll see how I do it in a second. Um, okay. The next problem is undo redo semantics. So I guess these other problems have been something that like the issue is in terms of networking and the like everyone having different copies of what's going on. But an issue with undo redo is that this might not be obvious, but it's not like clear how undo redo should actually work when you have multiple users editing the same sort of common state. And it's not just because you're doing state mutation. I just mean like what should the board look like after this person hits undo in this scenario? I don't think there's a clear answer to that always, and so I'll go through an example of that. Okay, so forget about like the client and the server. We're just sort of answering the question of what should actually happen. So let's say client A draws something. This is all. Whoops, it went all weird. This is just one like curve that they've drawn. You saw me draw the whole thing. I've just separated into like two sections because it helps conceptually. And let's suppose that. I'm going to write that client A wrote that. So like A writes that. The next thing that happens is client B erases like say let's say they just erase half of it. And then client A undo. Like client A hits undo. So all right, A hits undo. And the whole line that they drew isn't there. And but maybe that's not a huge issue. You can just remove the object that.
Maybe just to be explicit, it's intended that users can only undo things they did, not like previous actions in the overall stream of actions by all users.
Yes. So I should say if we just globalize all of this, so like we just ask the server what's the order in which things happened, and that order determines what's the latest thing that you can undo or what's the next thing you can redo, then that solves the problem. But that's I don't think that's actually desirable because especially when multiple users are interacting with the board at the same time, sort of unexpected things happen. You're writing something, you go, oops, I want to hit undo, and then suddenly you're undoing what someone else was writing. So we want the semantics of how undo should work when a single person is writing on their own. It should be equivalent to like what you expect to happen, where like you only undo and redo. What I mean is that this sort of multi-user undo redo should work. If only one person's using it, then it's sort of equivalent to how you would expect it to work. But the question is when multiple people are using it at the same time, what happens in these edge cases? So A wrote that weird thing, then client B erased half of it, and then A hit undo. So let's say that the whole thing disappears. Then they hit redo. I guess it's clear what actually happens in this case, that we should. I mean, maybe it's not clear. Maybe you think the whole thing should come back, like because that was the action that they sort of wanted to happen. What they originally did was they drew this.
Screw you, B. I really meant it. Undo redo.
Yeah, basically. But I don't know. Like in this case, we're like favoring what A wants to happen, whereas B sort of like I don't know that maybe they had a good reason to erase that part of it, and maybe A also doesn't have any will for that part to come back. Yeah, I don't like it's not clear whether half of it should come back in this situation or the whole thing should come back. In the model, in the way that I do it, half of it does come back. So we're sort of respecting that both A originally wrote this and B erased part of it. So we're like, unless both of those actions are, unless B also erases, this part of the line won't come back in the way that I do it.
I think you mean undoes. Unless B undoes. You said unless B erases. You meant undoes.
Oh, yeah. Yeah, if they undo their erase. Yeah. Okay, another scenario is, okay, let's sort of do the same thing, but let's say A writes something, B erases half of it again, and then A hits undo, so the whole thing disappears. Then B hits undo. I think in this scenario it's clear that nothing should happen, but like there's been sort of situations in which, say, the way I had it working at one point was when you erase something, you sort of store the contents of the thing that you erased in a sort of secret location, and then the way that undo works is that you would return that to like the board contents. And so in that scenario, what would happen is that second half of the line might return. And so this is a scenario in which when you're just mutating state and sort of and erasing is just amounts to chomping bits off the board, when you return that by sort of undoing your erase, you need to sort of check whether that thing is still there anymore. Because I think in this situation, it shouldn't actually return this this object to the board, because we're respecting A's right to remove what they wrote on the board. I'll do one more scenario, and this is where there's 3 clients. So let's say A writes something, then let's say B erases this part of it, and I'll just I'm not going to erase it, I'm just going to put something over it. And then let's say C erases like in this region, so the whole thing disappears. Then so at this point in time it's just blank. So after that, B hits undo. And so at this point in time, well, B hits undo. A hasn't undone their action where they wrote this to the board. So it's not like in this situation where when we undo, we check to make sure that that A hasn't undone what they originally wrote. In this situation, A hasn't undone it, but the issue is that C has also erased in that area. So depending on how, like, what it means to erase something, whether it's like saying, actually, sorry, let me change this. I'm gonna say that C did the erasing first. So that's their erasing, and this is B's erasing. Oh, actually, no, that doesn't make sense. Sorry, I'll go back to the first one. When B hits undo in this situation, they need to check that like nothing else has also erased that same line. I think actually this scenario isn't actually a problem, because after B has erased that area of the line, C is only erasing this part. So there won't be a conflict there. Actually, I've got a better example for this. I'll do this one last example and then we'll move on. So it's the same sort of setup. A wrote that that object, B erased part of it, and then B hit undo. Yeah, this makes more sense. So B sort of erased this section, but then they hit undo, so it came back. And now, so the whole line is there. But at this point, C hits erase, and they erase the entire line. So now the whole thing's gone. If B hits redo, the question is what should happen? Because it's been erased by C. So C is saying that it's gone away, but B is now saying sort of undo my action of removing this bit. Because both B and C have sort of performed the action of removing this part, it's unclear whether like it should be there or not. And so in this sense, it's kind of it matters what order, not only what order the original things happened, but also the order in which things were undone and redone. And that can make it a little hairy to implement. Okay, I'll move on and maybe come back to that. But the last thing is essentially dealing with all these problems, but at the same time allowing client-side prediction, so that when you're drawing a line, you don't need to wait for the server to figure out what's going on and then send back to you what you actually did. You need to be able to just see it immediately.
Maybe just comment, Billy, that the current version of the boards don't do this very well. And that's why, I mean, many people have noticed that sometimes you'll see things on the board that probably aren't what the speaker intended, or there's mismatches between when you have the board open or not open. So we get by, but there's a sense in which I very much agree with what Billy said earlier, that every time the boards do something weird like this, it breaks the illusion, and it really makes although it can seem like a small problem, I think it is very important to get right.
Yeah, okay. So let me now explain how we solve this. So this describes the state of the board, and it's split into sort of two components, which is this is a table of figures. And so a figure is just a general kind of a shape or something you draw on the board. So most of the time it's just going to be a curve, but we could support other kinds of shapes. But it just inside it is just some data that says this is what you should draw to the board. And here it's a table whose keys are like some kind of ID for that figure. So figure ID, task ID, player ID. These are all just strings, by the way. So you've got that table. Then you have a separate table of what are called drawing tasks. So each of these represents an action that a client is making, and it's some sort of schematic of how to change the state of the figures, either by modifying some figures, so you might be erasing part of one figure, or you might be contributing to it by adding a new figure. And so that's conceptualized in a drawing task. And these things change over time, because when you're drawing, you don't know the whole line from the start. So there's this sort of data of what's in a drawing task and what figure it draws changes over time. But we're not concerned about that right now. And the final thing is a history. And so this is kind of just it's just like a stack. It's sort of like a stack, but you have a sort of point in time. Like you might have over the history of what you've been drawing. You might have the first thing you did, the second thing, the third thing, and then the fourth thing. But maybe you hit undo and now you're back at this point in time where the fourth thing is in the future and the rest of it is in the past. That's kind of that's basically the idea of what a history is. So in the state, it sort of stores what each player has their own history of the actions they performed. And so you should think about these drawing tasks and these histories sort of, they are the most recent things that happened, and they like this shouldn't be too large because at a certain point it kind of becomes expensive to like make these sort of like everything here can be undone and redone quite easily. But there's a stage at which when your history becomes too full, we want to sort of commit it to the sort of state of figures so that the change you made exists forever and you can't undo or redo it.
Can I just make sure I understand this type notation? So curly bracket task ID doesn't mean a singleton with an ID in it. It means an array of task IDs. Is that right?
So this is the sort of key notation. So history. Okay, this is an array of task IDs. Yeah. So it's like a list. All of this isn't actual code that I've written. This is a simplification in many senses. So this isn't actually what a history looks like, but it gets the idea across. Okay, and so here I've kind of tried to indicate that a drawing task, like it sort of describes a bunch of changes to certain figures, either by saying, well, at this figure ID, you should apply this function that changes it from this kind of figure to this kind of figure. Or it's just a contribution of you should add this figure to the table of figures. Okay, and then there is some kind of function in which you can take a state and you can essentially compile it all down by applying all the drawing tasks to the figures, and that gives you like the result of what the board should look like according to like what's been set in stone and what's sort of temporary at the time but is like still there. Okay, let's move on. So here's two examples of drawing tasks. So this is just a draw a curve drawing task, and it says you should add a single curve to the table, who has name. It's called 1, 2, 3, and this right here between these brackets is this is the figure. It has some information about the points along the curve that you should draw to the screen, the width and the color and so on, and the Z index and the mask, which I'll explain in a second. So that one's pretty straightforward. It just says put this in the table of figures. This arrays something drawing task. It's saying what I think you should do to the table of figures is you should go to this figure, and what I'm just indicating here is you should take the... Alright, yeah, I should explain what a mask is. So, the way I made this... the way I conceptualize an arrays is because it's different to like a regular drawing task, which is just an independent contribution to the board that like doesn't depend on anything else and doesn't like at most the only thing that changes is really the Z index. Oh, my screen share just disappeared. 1 second. Just a moment. It's just loading. Oh, it's back. Okay. Yeah. So when you... Oh, I didn't reshare. Okay. How's that? Okay, so um, yeah, so drawing a curve, it's its own independent thing. You don't really have to know about what else is on the board other than the Z index in order to contribute it. But uh, the problem with erasing is that it's inherently sort of destructive in that you're changing the state of like other things inside or like other figures. And so the way I think about it is that it's really like taking that there's some curves on the board, and what it's really doing is it's applying a mask to them. Maybe I can draw this differently. It's sort of painting over it with like an invisibility cloak or something. I don't know why that's disappearing, but that's the idea. It's sort of it 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 puts in like an invisibility cloak over that layer so you can't see what's underneath. Um, and so yeah, the data of the mask is actually just it tells you which line segments along the curve should be erased. And so in this example, it's saying you should erase the first thing, don't erase the second thing, but erase the third thing, and then dot dot dot. And what it's doing here is it's merging it with the mask that's stored in the curve itself, which might just be nothing. In this example, it's saying like nothing should be erased. But the point of this is that you can have multiple of these drawing tasks that say I want you to erase this part, this part, this part, and they can all be sort of merged together to contribute to what in the end should be erased on the line. So you can apply multiple drawing tasks to a figure until they all erase distinct parts of it. And so I guess the point of these drawing tasks is that the act of just taking away the drawing task from the table of drawing tasks automatically undoes it, because what the board looks like is a function of this state. And so if you change the input so that a drawing task isn't present, which was saying erase this part or this part, then it won't get erased. So let me make that part clearer. Oh, and just something about that is that this kind of imposes a condition on drawing tasks, is that the order that you apply them shouldn't matter, and that ends up being true for erasing because, it doesn't matter the order that you apply these. They will always end up like the totality of all the things that get erased isn't influenced by the order that you apply these.
Hey Billy, is merge just all of the table?
Like yeah, pretty much. Yeah. So if these are just bitwise values and nil was just 0, then yeah.
Yeah, and then I guess you could say that it doesn't matter, like or is commutative. So
yeah, pretty much. Okay, so yeah, what I've written here, this is all in code, so you can't actually see any of this. And so that's where this step comes into it. So the idea is that we start in some particular state. We can take that data, and as I described, we can sort of apply all the drawing tasks to the table of figures so that all the actions that are sort of current have been performed, and you get the resulting table out. So you could render that to the canvas. And now the question is, when that state changes, when we introduce a new drawing task or take one away or modify one, it's really in terms of correctness, we've solved the problem of correctness here, because all we need to do is just call render again on the new version of the state, and that's what we're going to show on the canvas. But the obvious problem is it's going to be so expensive to just delete the whole canvas, update the state, and re-render it. And so the secret ingredient here is Roact, which is just a Roblox implementation, or it's a Lua implementation of the React framework, which is just a declarative functional way uh, of taking state and turning it into like these heavy, hard to create and destroy instances, because doing all that is slow. And what it does is when we change the underlying state, Roact takes care of this reconciliation step where it changes what was originally rendered to the new, what should be rendered according to the new version of the state. And so it does this by, I won't go into all the internals, but it has a virtual representation of all the expensive instances as a big tree. And when it recomputes that tree, it can sort of recognize what needs to be changed. And so I'll explain quickly how we can leverage this. Yeah, I see I'm running out of time. We are going into the Metaboard dev meeting after this. The meta. Yeah. Okay. Yeah. Um. Okay. So yeah, at this point, uh, we need to look at the code. But actually, I'll say a few things about this. Maybe I haven't really addressed. All right, how does this actually solve these problems here? Um. I I guess that the main thing it does is uh like simply what we do first is we do the bad solution from before, which was correct but slow, where the server is in charge of what actually happens, and the clients sort of get this slow, like lagged behind updates of what, like they eventually get back the right events in the right order that say how the state should be changed. So, yes, so the client sort of, uh, yeah, this update state step. This happens according to when each client like puts their pen to the screen, that fires events that trigger changes to drawing tasks, or it makes new drawing tasks, or it updates old ones. And the order that all happens gets sent to the server in whatever order. The server decides, well, okay, well that's the whatever the order the server receives it, that's the order that it happens, and it sends back that same stuff, those same events in that order to the clients, and they can rely on that order. So essentially, the making sure everyone has the same state is achieved by just doing it slowly and waiting for the server to like tell everyone the same stuff in the same order, and they all manipulate the state on their own. Um, the so the way that I'll show you now the way that we solve the sort of client prediction part, where you don't actually have to wait for the server to see the changes you made. So I'll just change over to Roblox now. Okay, so this, actually, let me resize this. Let me go into the relevant part of the code. It's in this app here. Yeah. Okay, so this is a Roact component. I want to explain how that works. But you can see I've got my figures here, I've got my drawing tasks here, and this step is just the part where I'm adding all the figures that the drawing tasks are proposing to contribute to the table of figures. I'm doing that here by adding all those, and here is where I'm in effect applying all the like masks from all the erasing type drawing tasks. And then at this stage, I involve a completely separate table. This is called Unverified drawing task, and this is essentially what the this is the drawing task that you are creating yourself, that you just make immediately. You don't wait for the server to like tell you what you did, but in the right order with respect to everyone else. But the critical thing is that that's in a separate table, and what I'm doing here is I'm doing the same thing. I'm applying it to the table of figures, but this is a separate table in memory. So this isn't actually modifying any of the original figure table. It's creating a new figure table, which is just an amalgamation of all of the changes made by everyone else, but also finally the changes that you made locally, so you see them immediately. And so that gets all compiled down to this all figures table, and then that gets rendered. And so you see, so basically the state is in two components: your sort of local unverified stuff, and the sort of verified stuff that's coming into the server, and you're combining them in the render step. You're not actually sort of destructively merging them all together. And so what this means is that when you finally get the correct version of what you did back from the server, like you get the verified drawing task back, and it sort of sits in this verified drawing task table, you can just throw away the unverified one. And so what'll happen is that while you're drawing it, you're seeing the version of your line from this unverified drawing task table. And then at some point in time, my program decides to just drop it from this table, and then you just instantly switch to seeing the verified one. And so that might result in a change of Z index, so it might jump to a different layer. And the beauty of Roact here is that it doesn't destroy the original line and then create a new one at a different layer. It just changes that property of all the instances so that they're raised to a higher layer. And so it's
know that the parts that your client built corresponding to the unverified line are the ones that are meant to be transformed with a slightly different Z index into the parts that has just been told exist by the new verified line that has been added to that table.
Yeah, I can explain that. So I was just showing you the sort of drawing app component, but what this eventually becomes, what all this data gets fed into, there's a few nested stuff, but I'll explain what these mask bundles are in a second. But these figures, they get sent to, for example, a part canvas, this is the thing that renders it onto the workspace version of the board, so the 3D version. And so, yeah, this is the component that creates a line. So this is essentially creating a virtual version of this part instance. And let me go top down actually. So this part canvas component takes in all the figures. And yeah, this is the thing it returns. It returns this virtual node, which is just a folder that contains all of these children. They're called pure figures, but these are just the figures. And these all have this figure ID as a key. So in the table, because this figure ID is named with the same key, if I change this incoming figure here, because it gets rendered at the same key, if the instance is the same, then if it's the same kind of instance but it's just different properties, because it's at the same key, it just recognizes that that's the same instance.
Yeah, okay, that makes sense. It just recycles the ones. If the server, for some reason, like shuffled the parts around within the line, Roact would also do that, but presumably that would be imperceptible because it's just as quick to change the Zed Index as it probably is to change any other of the exposition or the rotation or whatever. So yeah, anyway, that's clear. I just was wondering whether or not you were telling it what the mapping between those parts was, and it sounds like you are with the ID, or if Roact was somehow dynamically deciding to recycle parts.
Yeah, I tell it what it is with the ID. If you, at the lower level, say a curve creates a bunch of lines, the key for those lines, what am I doing? The key for those lines is just an index. So because this index stays the same, like the ith line, whatever component I could replace this with, if it's similar enough, as in it's also a part object.
Yeah.
It'll just change the properties of it.
Cool.
Let me just pause for a second. Feel free to ask a question. I'm just gonna think about what I wanted to touch on next.
Oh yeah, I did have one other question. So you said that you will move at some point from a unverified line to a verified line on the client. But presumably, as the client is constructing the unverified line, parts of it, prefixes of that line are being verified by the server. So do you wait until the line is finished by the client before you switch to the verified line, even though you might be able to, in principle, verify parts of it earlier?
Yeah, exactly. Depending on the kind of thing it is, with erasing, I think I'd do it differently. But if you're just drawing something, I can show you the part of the code that handles it. If you're just drawing something, I can there's a method in here which sort of every time you pass in every time you re-render, it checks this unverified drawing task table, and checks if there in the verified drawing task, if there are any drawing if that drawing task is finished. So this is a drawing task have internal state telling you whether or not it's done. And here I'm actually just removing it from the table of unverified drawing tasks. So yeah, exactly as you said, as soon as you lift the pen and half a second later it comes back from the server, at that point in time when it comes back and it's changed to a finished state, then you delete it from the unverified drawing task, and as a result the verified one gets used because it's not there anymore in the unverified table.
And sorry, you might have already explained this, but the verified one is there the whole time. Why isn't it rendered by Roact, for example? If are they both there at some time? Is there at any point where there's an unverified task and a verified task?
No, so this all figures table, after these two for loops finish, I first all the verified ones get sort of applied here. So I set the verified ones are going to draw it there, but then this one is just going to override it. And so this is just back-end data. Yeah. You might have noticed that yes, I am cloning the entire table of figures. And you might go, oh my God, that's like, is that going to like be a major source of slowdown? And I've actually got this benchmark test up here that I can show you the contents of. This is an example where I'm creating a bunch of figures. I think it's about 18,000 figures get created, but in total they have like a million lines between them, which is way beyond whatever like anything we'd ever use. Sorry, it's way beyond the number of lines we would ever need on a single board. And this function here is just cloning that table of figures and then just like modifying one particular key just by adding some value there. And you can see that's this blue histogram here. So you can see in this example, it takes a pathetically small amount of time. It's 55 microseconds. And so, yeah, it's all a matter of scale. Maybe I should say the reason why I'm cloning it is to avoid, I don't want to mutate the original state, because if I want to change one of these drawing tasks, like if I want to add or remove the drawing task, I don't want that to I don't want to destructively change the underlying the sort of committed table of figures. And so I need to clone it. And so yeah, you can see this cloning operation is very, very fast. It's slightly, you can see it's quite a bit slower to, this one is just manually copying each thing. Oh, actually, I could have just had this as like dots with an empty table. For some reason, I was cloning it as well. But yeah, this one is like manually copying the entire table into a new table. That's like a bit slower, but it's still less than a microsecond for about 18,000 of these things are in this table. And so the reason you do this is so, a key part of this, why this is efficient, is because when I call the re-render, I need it to check, like, ideally it only has to like re-render the stuff that has changed. And so if like you might say, well, maybe instead of like cloning the whole thing, you could just like hang on. I can't exactly follow that story through, but the usual alternative to like to doing things immutably is that you need to check like that two tables are equal by. You end up needing to check the quality of two tables by checking if each of their entries are the same, and this is just demonstrating that that's like slower than like just copying the whole table originally. So you might as well just do that. Okay, any other questions for now? I might explain the whole mask bundle concept. So in the slides, let me go back to the slides for 1 second. So I was talking about you can there's this step where you can take the state and you compile it to just the table of figures at any given time. if you actually wrote a function that does this, the table that you get out is not only going to be a different table, but the entries are going to be different because, say in this example, when you apply this drawing task, you get a completely new figure every single time. Because you're creating it, it has a different mask applied to it. Because depending on if you change the drawing task, you'll be changing which line segments you're erasing. But even if you pass in the same you apply the same drawing tasks, if you do that once and then do it again, because you're calling this function, you're going to get a new figure, a new table out every time. But the problem is like that table has the same contents as the one before. Like even though you're creating a merged mask of all the different masks from all the different drawing tasks, it ends up being the same one in the sense that it has the same entries, but it's going to be a different Lua table. It's gonna then if you just call the equals function between the new one and the old one, it's going to say false every time. So that's a problem because this is a situation where if I have a bunch of stuff erased by a bunch of different drawing tasks, every time I call render, even if I haven't changed any of those drawing tasks, if I'm applying these every time, I'm going to have to like re-render the entire line because I need to check if any of this has changed. And so I do a trick to sort of make sure that you aren't doing computation on the order of the number of lines you have in the whole table, because potentially there could be a lot of lines being erased, and I don't want to like recompute 10,000 things, but maybe like 100 or a couple hundred things is okay. And so I'll show you how I do that. So at this stage, where what I do is, you'll notice at this reconciliation stage, the stage where I'm taking all the figures and all the drawing tasks, and I add the figures that some drawing tasks are contributing to the table. Instead of applying the ones that are like erasing things, I collect those into a separate thing, which says, which sort of collects all the masks by figure ID. So each drawing task might be erasing multiple different figures in different spots, and so I'm just gathering what they're doing, gathering those tables all into all in like I'm gathering them by figure ID. And then I pass them into the component that renders all the figures as a separate thing. And so the point is, the gain is that this doesn't change every single re-render if the table itself will change, but like the curves inside it won't change because I'm not destructively changing them with the erasing drawing tasks. And so if I go inside here, you can see they get passed into this pure figure component, which actually takes all those masks and merges them all into one mask that's going to be applied to the figure. And then this returns the sort of fully rendered curve. And so the point is, because this cumulative mask every time, this cumulative mask, sorry, not the cumulative mask, the the whole collection of figure masks. So these are all the masks that are affecting this particular figure. I have a should update method, which essentially checks if any of those masks have changed. So if you can see next props, that's the new version of figure masks, and this is the old version of figure masks. If any of them are not equal to the old version, then you know that you actually do need to update. But if they're all the same, then you do actually call a re-render and you do all this computation. So what this means is that like you still have to do you still have to do this many iterations, as in the number of figure masks, and that's probably like at most 10 or 20 at a time. You have to do that many checks to check if you need to change anything. But the good news is you don't have to do on order of the total number of lines that many checks. So it's all a matter of scale in terms of trying to recompute the sort of least amount of stuff, while keeping the majority of the data is equal as a Lua table, as a Lua object. Sorry. Any other questions or anything I can clarify on that?
I think I lost you a bit there, but I think I'll rewatch the video and ask you later.
That's okay. I guess the first half of this talk I planned out a bit more, but this is, I guess, a bit more freestyling when I'm just going through the code.
Yeah, I think it was clear. I'm just maybe I should. I have something. It's an area where I think I just have to read the code. It's a bit hard to follow.
The basic gist of it is that, yeah, as I was saying, when stuff changes, if you need to, the amount of equality checks you need to do, I'm trying to make that as small as possible. And so by decomposing it into what's being erased and what the original figure is, the number of equality checks I need to do is only on the what each drawing task is erasing in terms of the mask that it creates, rather than like checking every single line if it's like still there or not.
Oh, okay. Yeah, I think I was confused because in some sense Roact does this internally, but the point is that the masks are not Roact things, whatever that word for that is, components.
So I could do all of this internally. I could leave all of this to Roact in principle, where like, yeah, it makes new tables where even in cases where the old table that it's now not equal to still has the same content. But that becomes a problem when it's doing, like, when it does work on order of the number of lines, as in if you have to do 10,000 re-renders, after which you check if it's equal to the thing it was before. But if I'm just limiting it to like as much as possible to the changes in the drawing tasks. I guess I was gonna mention, I guess as I was saying before, the order in the reason why this works and why you can just sort of add and remove things from the table of drawing tasks in order to like undo and redo stuff is exactly because the order in which you apply the drawing task doesn't matter. And so a specific instantiation of that is this means that when you have drawing tasks that are like contributing a figure, as in like they're drawing a curve, they have the Z index baked in at the time that they're created, and so the server makes sure that decides like which Z index each drawing task gets based on the order that they come in when they're initialized. Where was I going with this? So yeah, and so because the Z index is set there, when you like take it away from the set of drawing tasks and then chuck it back in, and you have multiple different drawing tasks with different Z indexes, it doesn't matter what order you do it, like what order you sort of contribute them to the complete table, because they have the sort of order baked into them where this one is at this Z index and this one is at another Z index. And so like that, it solves that problem. But if I want to do something like, if I want to do a kind of editing that does sort of that depends on the order things happen in another way, like for example, task that changes the color of a curve, and say I have multiple people particular curve, I need to sort of know who did it first, and so I have to sort of bake that into the data of the drawing task, is that like I'm the first person that changed the color of this, and so that I know that when I'm applying all the drawing tasks to the table of figures, and I've got multiple drawing tasks which are like change the color to blue, change it to red. There needs to be a decided order of what that happens in, so that if I compute it like multiple times and something else has changed, and like if the order that I apply things changes, I need to stay consistent with that. And so yeah, by storing some kind of number there, that sort of fixes it temporarily. It's, we can talk about this more later, but I guess the difficult part is what you do when the drawing task is old enough that it needs to be committed to the table of figures, so the change happens forever. If the second person that changed the color, if their like drawing task is being committed first, I don't know how to make like the first person who edited it, whose drawing task is still live, I don't know how to make them still have precedent. Sorry, they need to not have precedent, because their change happened first, and then the second person edited it. Okay.
Anyway, maybe can we zoom back out a bit and maybe explain? Well, so this was a lot of effort, and this new version of the boards is going to be live soon, and as an open source project, and Billy is the chief maintainer of that project. You want to say a bit for people who might be looking to contribute or interested to know how they might contribute, and where is Metaboard going, and what was the point of all this hard work, and so on, before we conclude?
Okay, well, I guess what's coming up, and what I didn't talk about today that I'm working on, is efficiency in terms of we want to have like different levels of detail, so that like the boards you see around you are rendered at full detail. But if you have low spec hardware, then we want the experience to still be smooth, so we want to de-render things that are far away. Part of solving that problem is coming up with a good way of rendering rendering this sort of board data that I've been talking about in a sort of low detail way that essentially it needs to use less instances. And so there's like some ideas or something like you take the curve and instead of rendering all the line segments, you sort of skip a couple points. But there's sort of like you have to figure out how to you have to also work with the segments that are being erased and stuff. Or you might like come up with some way of you might like do a pixelated canvas or something where you decide what color each pixel is. I've tried a couple different versions, and I like there's a couple. It's somewhat of an interesting problem. So if someone is interested in like working on a low detail rendering, I'd be happy to explain how to do that part. But I guess so. So what I need to do is provide some, I guess, some documentation on like the part of Metaboard that you could sort of copy what I'm doing and change things around, like this part canvas component. You could make one that instead of rendering every single line, just renders some of them. I'd be interested in contributions based on that. And then we also have you could write an interesting drawing task that I guess draws a like a square or a circle. Yeah, we have a couple of in-demand tools that I haven't got around to writing that it would be good to if someone wanted to contribute on that.
Awesome. Thanks a lot, Billy. Is there anything else you wanted to add, or should we wrap up there?
Can wrap up there.
Any
Thanks for
final?
coming, everyone.
Yeah. Any final questions for Billy?
Thanks, Billy. Great talk. And I guess, like what you were saying at the start, I think these metaboards are really, like, they're really powering metauni, in my opinion. So, nice work. And I'm very impressed by what you've had to say today. In a couple of places, I was like, yeah, this is much more complicated than I thought coming into the talk. I was expecting you to sort of lay out a basic authoritative client kind of system. But yeah, it was sort of surprising the complexity you had to deal with. So yeah, nice work.